So the next, now we have to start with the thermodynamics. So what this thermodynamics mainly consists of? So the thermodynamics, where we just see that, so this thermodynamics word itself, it consists of two terms. One is nothing but your thermal energy, and this thermal energy obviously which is nothing but the heat energy, and this heat has been converted into form of some mechanical work. Obviously we have to do some work, so one form of energy has been converted into another form of energy. In this thermodynamics, or simple, it is a conversion of your one form of energy into another, or heat into some mechanical work. So you might have seen that engine, for example, which we are using there in all the vehicles. So the fuel is getting burned, and that which will produces lot of heat. So with the help of which, so we are just going to move that cylinder in and out at the same time, which is connected to that your shaft, and with the help of which that your tire are going to move. So this is how we can say that your this vehicle will work. So in this thermodynamics, so we know that the heat is always going to flow from your higher temperature towards the lower temperature. So this is one of the important thing for your thermodynamics, so that we will also cover. So if we just consider the definition that we have just discussed, it is just deal with the concept of your heat and temperature, and the interconversion of heat into other forms of energy. Again we say that, so it deals with the bulk system and doesn't go into the molecular constitution of matter. So if the complete, so let's say this is the gas has been heated now. So I am not interested to know what is the particular temperature and pressure of particular this molecule A or this molecule B. I am just completely interested, so what is the temperature of your entire system now. So you have to consider this one as a whole system. Yeah, so this is nothing but the whole system, so which we will call also it as a thermodynamic system over here for this case. So what is this thermodynamic system? So this is a assembly of a large number of particles having a certain value of pressure, volume and temperature. So this is the system. So it is just characterized by its a particular value of pressure, temperature, and that is obviously volume. Yeah, so this is how we have shown over here this system for this particular case. For example, the gas which is enclosed in a cylinder, yeah, so that also you can consider it as a system over here. So what are the different types of system now? So the first one is an open system. So in open system there is exchange of heat as well as mass with the surrounding. Yeah, so when you just heated this vessel, yeah, so definitely what you can say that, so the mass is going to reduce, the heat is also going to, just you can say that its temperature is also going to increase. So there is an exchange of heat and mass with the surrounding. Again the closed system, you can say that there is only exchange of heat, but there is no exchange of now mass. So this is nothing but the closed system. Again the third one we can consider it as a isolated system. So the isolated, yeah, so the isolated one, so it can neither exchange nor exchange your that mass as well as heat with the surrounding. So this one we are going to call it as a isolated system over here. So this is, these are the types of your system in the thermodynamics, yeah, that we have to see. So now what is surrounding? So everything outside that system which can have a direct effect on that system, that we are going to call it as a surrounding. So because of that surrounding, definitely there might be possibility its temperature is going to change, or one of its characteristics is going to change. So there is a system boundary, that boundary separates the system from the surrounding over here. So what are the thermodynamics variables? The quantities like pressure, volume, temperature, which helps us to study the behavior of thermodynamic systems, are called as a thermodynamics variable. So for example, the equation of states, yeah, so that is nothing but PV nRT. So that is also, we can say, ideal gas equation, which helps us to study that thermodynamics system. So this one also, that is useful for studying that your thermodynamic system over here. The different types of walls which are there. So one is nothing but your adiabatic wall. So adiabatic wall means there will not be exchange of heat. So that is nothing but you can say this is a adiabatic wall, which is also called as a insulating wall. You are taking a thermos and keeping that tea in the thermos. So the wall is nothing but the adiabatic, which keeps your tea, yeah, so as a hot one. So this is what we call as an insulating wall. So that doesn't allow the flow of energy from one chamber to the another. So this is your adiabatic wall. If you consider the diathermic wall, the conducting wall that allows the energy flow from one chamber to another is called as a diathermic wall. Now what is thermal equilibrium? So the two bodies which are in thermal equilibrium, if their temperature is same, yeah, so that is what we can say that, so there is nothing but the heat flow from the hot body towards the cold body, and this flow of heat continues unless and until finally the temperature of the two bodies will remain or it get same. So that when can say that the thermal equilibrium has been achieved over here. So this is how we have shown that the thermal equilibrium A and B, these are the two systems which consist of gases, yeah, in these two chambers. And if I just place this is nothing but, let's say, the diathermic wall, so definitely then there is a flow of heat from one to another or from second to first based on its temperature, and this flow of heat continue unless and until there finally the temperature of these two chambers that will be same. So this is called we as a thermal equilibrium for this particular case. So this is what we have seen, that thermodynamic equilibrium, the same thing. So system is said to be in a state of thermodynamic equilibrium if the macroscopic variables describing the thermodynamic state do not change with the time. So obviously that pressure, volume, temperature, so they are not going to change with time. So then we can say that it is in the thermodynamic equilibrium over here. So the same thing, so the thermodynamic equilibrium possesses following equilibrium simultaneously. It is in now mechanical equilibrium, it is in the thermal equilibrium, as well as in the chemical equilibrium. There will not be any chemical reaction further in that. Yeah, so this is what we can say about the equilibrium.